Hello, today we'll be talking about correlation coefficient. I'm Janice Mack.
I'm Beth Ross.
And I'm Tia Cooks. Correlation coefficient. Two variables can be positively related, negatively related, or have no relationship between them. When you look at the correlation coefficient, the covariance and correlation coefficient show how a relationship between two variables can be measured in a statistical manner. Because covariance is not a standardized measure, it cannot be used to compare it in a reliable and objective manner. The standardized measurement of covariance is the correlation coefficient and has a resulting value that must be between -1 and +1. When it has a value of -1, it means that there is perfectly negative relationship, whereas a value of +1 means the exact inverse. A coefficient value of 0 means that there is no relationship between the two variables. It is often used to measure effect size since it is a standardized measure. Plus or minus 0.1 equals a small effect. Plus or minus 0.3 is equal to a medium effect. And plus or minus 0.5 is equal to a large effect.
It is always important to remember that while these can be useful benchmarks, the main thing to do is to interpret the results within the context of the study, taking into account all the data. Another important thing to remember is that correlation coefficients does not mean that one variable causes another variable to increase, decrease, or stay the same. For example, in a particular study, there may be a conclusion that as the temperature increases, the sale of sunscreen increases, but this does not necessarily mean that hot weather causes an increase in sunscreen sales.
This slide describes the different types of correlation coefficients. The first one, Pearson's correlation coefficient, or R, is used when both variables are interval data. The assumption of normality holds true when this is used. Spearman's correlation coefficient is used for non-parametric ordinal data. And Kendall's correlation coefficient is used when both variables are ordinal data. But in contrast with Spearman's correlation coefficient, it's preferred for smaller sample sizes. Point biserial correlation coefficient is used when one variable is a continuous one and the other is a discrete dichotomy, for example, present or absent from class. And finally, biserial correlation coefficient is used when one variable is continuous and the other is a continuous dichotomy, such as the range from underweight to overweight. Thank you. And these are the references we used.